This is one-to-one and inverse functions, part 2, finishing the notes. And we left off here of one more, finding the equation of the inverse. When there's more than one x in the problem. And our steps for converting or calculating the inverse are we have to, first of all, change g of x to y. So we'll start there. G of x is y equals 2x plus 1 divided by x minus 1. Second step, we're going to switch the x and the y. X is going to go where y went, y goes where x went. So we end up with x equals 2y plus 1 divided by y minus 1. All of the x's change to y. Our third step is to solve for y, and that's going to take us a couple minutes to do. But what we did previously is we cross-multiplied, so let's continue to cross-multiply. And when we cross-multiply, then we don't have to deal with a fraction anymore. We end up with x times y minus 1 equals 1 times 2y plus 1. And we're going to distribute. Here, and the nice thing is, on the right side we have 1, so when we distribute the 1, it's just going to remain the same. But we end up with x, y minus x. On the other side, we end up with 2y plus 1. And what we're in the process of doing now is step 3, which is to solve for y. If we have a y term on the left side, we have a y term on the right side. We need to get all of the y's on the same side. So let's move the x over here to the right side. And let's move the 2y over to the left side. And it doesn't matter which side you move them, but just get all of the y terms on the same side. And now we have x, y minus 2y, because we've put all of the y's on the left. And over here on the right, we're going to end up with 1 plus x. And we need to get this problem, or this equation, to a point where we've got one y term. So what we learned in our last class is that we can factor out the y. And when we factor out a y, we're left with x minus 2 equals 1 plus x. And then it's y times x minus 2. So our inverse operation is to divide. And now we have our inverse, which is 1 plus x divided by x minus 2. And this one, are we dealing with h? G. So this is g. Here's our inverse notation. What I forgot to do at the beginning is even deal with that box off to the side. Because what we need to identify is what's the domain of our function. And after we deal with the domain of our function, then we can use that domain to find the range of the inverse. That tells us the range of the inverse. And the way that we find our domain is we take the denominator, the bottom of the original function, which is x minus 1, and we set it not equal to 0. So we can add 1 to both sides. And this is coming again from the original function, the problem that was given. And we can put that back up here in our domain. That's the domain. X doesn't equal 1. And once again, if you didn't hear me before, MathXL lets us use that notation, luckily enough. But the domain of the original function is also the range of the inverse. So remember, when you get down to range is a y value. But is y doesn't equal 1. So we know part of the answers here. Well, the other part that we can find is we can figure out what's the domain of our inverse. So here's our inverse function down here at the bottom. And to find the domain of that inverse, we're going to take the denominator of x minus 2. We're going to set it not equal to 0. This is the domain of the inverse. We're going to add 2 to both sides. And we get x doesn't equal 2. This is the inverse. Let me label. This was the original. And once we find the domain of the inverse, we get x doesn't equal 2 here. But when we're taking the inverse, we switch the x's and the y's, so we also switch the domain and the range. The domain of the inverse corresponds to the range. Just remember to write y doesn't equal 2. So lastly here, what we can do is we can type this into the calculator, and we can look at our picture. We are going to assume that it's yes. I'm not going to type it in on the video, but you can type it in on your own. But we need to see that our function is symmetric with respect to the line y equals x. So try that part on your own and then start the practice.